Hello, my name is James Cowling. I'm the sales director at Martech, and with me today is my work colleague.
And my name is Ndovo Zonkosi. I'm a data center manager at Martech. My role involves online partial data analysis and report compilation. I also conduct report discussions and provide appropriate recommendations to the clients pertaining to the findings of that particular assessment.
Today, we're going to really be focusing on what we classify as medium voltage switchgear and what Martech do as far as condition monitoring. Martech have specialized in the realm of electrical condition monitoring, and medium voltage and high voltage switchgear is a key component in most companies' assets. And that's where Elvis and his team look at the data and analyze it and actually issue a report that actually is of value to the customer because it tells them what they need to do. So Elvis, if we have a look, medium voltage switchgear, what is the failure mechanisms? What is the risk? What is it that you see when you do the assessments?
So basically, James, a high voltage or medium voltage switchgear has been identified as one of the critical assets that companies look at when they analyze operation risk at their facilities. And partial discharge has been identified as a cause of about 85% failures or faults of switchgear.
Elvis, how many failures do people see in switchgear? You always hear about load shedding and you hear about the municipalities and the damage to the switchgear and the cables and those sort of things. What are you finding as Martech and what you're seeing in industry in general?
So with the assessments that we've done as Martech in the past, James, we've actually came to realize that about 85% of the switchgear faults are as a result of partial discharge. So with the type of equipment that we use at Martech, we are actually able to detect this type of failures before they actually turn into this type of faults before they actually turn into premature failures.
So does the customer actually have to switch off his electricity in order for you to do these tests? Or how do you do it?
This type of tests, James, we actually do these tests with the plant running under normal operating conditions. We call this type of assessment online assessments. So the advantage of doing this type of assessment is that you actually look at the condition of your insulation system while it's under all your thermal, electrical, ambient, and mechanical stresses, which is quite key in terms of analyzing the condition of the insulation system.
So those, what we call team stresses, are critical from the point of view of doing the analysis and doing the actual conducting the PD tests on the switchgear.
Yeah, so these are widely known as the team stresses. So look at, in actual fact, your thermal conditions or your temperature condition has got an influence in the intensity of your partial discharge in your switchgear. Also, the way in which the switchgear was installed, that might also cause some partial discharge if the installation manual was or the installation process was not followed properly.
And what is the biggest issue that you see? If you have a look at the switchgear itself, it's normally metal clad switchgear 11, 22, 33, SF6 on the 132 kV side. But if you have a look at the components in the switchgear, you've got your breaker, you've got your bus bar, you've got your terminations, your cable, you've got your protection panel, which is looking after the protection side. But where do we, as Martech, find the most issues if we look at partial discharge and identifying defects in switchgear?
So from a partial discharge point of view, James, we divide the switchgear into three sections. So we first look at the bus bar compartment, where you've got your insulators and your bus bar support. We also look at the breaker compartment itself, where we take now the breaker contact into consideration. We also look at the termination sections because that is the three critical areas that are mostly prone to partial discharge.
And once you've done that testing, so the technician is in the substation, but we don't open anything up. He captures that data, and then that data then comes to your department for reporting. But if we have a look at it, the benefit to the customer, what is it that the customer gets? Do you give him some numbers? Do you give him millivolts or pulse count? What is it that the customer actually receives at the end of the day?
So the customer will actually receive a more comprehensive report because when you look at the data, we've got tools that we use to analyze the data. And from those tools, we're able to pinpoint where exactly the PD activity could be coming from within the assess system. from the switchgear components? Is it from the termination error, or is it the breaker that has got some issues? So we've got, for an example, the frequency spectrum or frequency domain spectrum, which is able to tell us exactly where the PD activity could be coming from. So we look at that, and we're also able to identify or explain the type of a defect. Is it internal PD, is it corona, or is it just surface flaking? And from there, we're able to tell the client that we've got this type of a problem within your switchgear.
Now, for the customer, what does he, for example, are there levels which he must be concerned about? Because switchgear can operate for a period of time with partial discharge or arcing or tracking, but it's eventually going to get to a stage where it's going to cause a failure or an explosion, which from a safety point of view, if someone's in a substation, they could get killed, they could get, arc flash incidents. So what is it that the customer can say, well, okay, this one I can run for 6 months. What is it that we actually give them? And when is it critical that we have to tell them, okay, you have to switch off and open up?
So what we actually look at, James, from the data that we get from site, we are actually able to quantify the severity or the intensity of the discharge activity in terms of Qmax, which is the amplitude. But we also look at the pulse count. How many times does it occur in one 50 Hertz cycle? So from that, we are able to tell the client that you've got low PD, and we usually classify it as risk condition level 1 to level 5, whereby your risk condition level 1, it's low PD and it's acceptable. Level 2 is low to moderate. When we look at level 3, that's where now we're saying it's now starting to be moderate to high, and then where your level 5 will be a major and finding and requires interventions from the client side.
Okay. So from a MarTech solution point of view, we, in theory, are able to identify this partial discharge occurring in the switchgear, and that we do with service teams. But then we also have critical assets, some of the mining, some of the smelting operations where they have large furnace transformers or something. What do we do on that side? Because I mean, those are actually critical. So is there some form of permanent online monitoring?
Yes, James. In actual fact, international standard recommends a trend over time for PD activity, because we know that PD activity it actually increases over time. So what we do in a situation like that, we've got permanent monitoring where we install permanent PD sensors, and then we obviously connect that to a permanent PD monitor on site, and then from that we can actually pull that data to a cloud system and be able to monitor that critical asset remotely.
Okay, so it's effectively an IoT system.
Yes.
Where we supply the sensors and the hardware, and we can actually, before the customer even knows, we can indicate or send them a report or an alarm and say, wait, you need to go and look at this. It's gone from a level 3 to a level 5. When's your next shut, for example? And if the shut's far away, we're going to have to arrange to have a mini shut and do an investigation or an inspection, correct?
That's correct, James. And these alarms are actually set according to IEC specifications. So we actually look at the trend over time. If there's significant deviations in terms of maybe pulse count, your pulses per second, or your amplitude in Qmax, or your PDI, which is actually the partial discharge intensity that is measured in megawatts. So if we see a significant change, then we're able to notify the client that no, we are seeing a significant change. Then we go to site and we take advanced data and we do proper analysis, and we are able to tell the client that, okay, this is what is actually the problem is in your system.
So we can actually tell them what it is. It's a level 1 or a level 5, but we can also then tell them where it is. Is it in the switchgear? Is it in the cable? And if it's in the cable, then what would we do? Because a cable could be kilometers long.
So once we see that it's actually in the cable, what we usually recommend, the client to switch off, and then we conduct an offline partial VLF, tan delta, and pressure testing on the cable. And also we do PD mapping, which is actually able to map and tell us the exact location of the PD activity along the cable length.
Thank you very much. From a MarTech point of view, thank you for listening into our chat today. If you need any further information, please contact us or visit our website, www.martech.co.za.